Welcome to M. Garrett CompSci. This is CS Principles, Unit 2, Lesson 6, HTTP and DNS. As a warm-up in the classroom setting, your teacher would hand out a little strip of paper with an IP address on it to each student. And then each student needs a piece of paper or a journal with a T-chart on it, where you'll keep up with the names and IP addresses of every other student. And the goal is to figure out the IP address of every other student in the classroom. So you can walk around the room and you can talk to one classmate at a time, and you can ask their IP address, but you can also copy down all the information that they have found so far. And so by doing this, everyone should be able to find the answer to what is everyone's IP address pretty quickly. Only problem is that the teacher will be walking around creating a little bit of chaos, occasionally taking away somebody's IP address and giving them a new one, or swapping people's addresses. That's to mirror the real-world reality that IP addresses sometimes change when we join different networks or reset our routers or go somewhere else in the world with our cell phone. So we need a system to keep up with the IP addresses we want to access and communicate with. And if we want the internet to scale up to billions of devices, we need that system to handle all of that complexity, to keep up with all of those IP addresses, even as the internet grows very quickly, and even as IP addresses sometimes change. So the answer to this is the Domain Name System, DNS. And that's what this first half of the lesson explores. Our activity for this lesson is first to watch a couple videos from code.org, which are available on your lesson resources for Lesson 6, right here and right here. And then to explore and use the final version of the Internet Simulator. So, as you watch that video, the first one is the one on IP addresses and DNS. Consider these questions. How does DNS solve the problem of translating domain names like example.com or code.org into IP addresses? Remember that when we access a website like code.org, what we really are doing is connecting to a computer somewhere in the world that has all of the code.org stuff on it. The pictures and the text and all of that stuff that make up the website. So we need to know the IP address of the computer storing all of the code.org stuff on it so we can connect to it and ask for those files. So that's what DNS does for us, helps translate the easy to remember code.org, for example, into the IP address where code.org stuff lives. And then how does DNS help the internet scale? How does it help the internet continue to work even as it gets way larger, more and more and more devices? So go and watch this video. You can pause this one and come back. I'll go ahead and summarize. This is a screen grab from the video. So this is your computer right here. And you're typing in code.org for the first time. So you don't know where code.org lives, what its IP address is. So this is the question you want to know the answer to. And so what your browser is going to do, since it doesn't know where that lives, it's going to ask a nearby DNS server, a computer that keeps track of the domain names and their associated IP addresses. And it might know the answer to that question. It might know where code.org lives. If it does, it'll turn around and give you the answer, and then you can connect directly to that IP address. If it doesn't know that answer, it'll go out to a little further away from you and ask another DNS server, because DNS servers are distributed throughout the world. They are not centralized. And it'll ask that same question of another DNS server that's nearby. And if it knows the answer, it will pass that back to the DNS server that asked the question, and it'll write it down. It'll put it in its list. And so next time somebody asks it that same question, it'll know the answer. And it'll write that down, and then it'll turn around and give you the answer. It's because you asked for it. So by this process, DNS servers together keep track of all the world's IP addresses. So if they don't know the answer, they just go out a little further and keep asking around until somebody knows. And everybody in that chain, all the servers and devices in that chain, then now know the answer. So that's how DNS helps the internet scale, because DNS servers are scattered, distributed throughout the world, and they can keep track of the devices nearby them. And then all the other DNS servers can keep asking questions of other servers until they find the answers. So again, we're going to look at the final version of the Internet Simulator on code.org. And before we communicate with somebody so far in the Internet Simulator, we've asked someone out loud for their IP address. And now we're going to find that we have a little DNS server on our network that we can ask for IP addresses from. So let's look at that. On your lesson resources, you can go here to the Internet Simulator. And level 1 is the simulator. And you can read those instructions. I'm going to go back to the slides for just a moment. This is what your network will look like. Say you're on router 1, and say this is you. Coder 4 is you. And so of course you know your IP address, your 1.4. But this is Coder 3, your friend that you want to talk to. And so it knows the name. So that's kind of like a .com name that you know and you want to get to. But you don't know the IP address of Coder 3. And so who are you going to ask? You're going to ask the DNS server over here on your network. The DNS server is always going to be your router number .15. So you're going to go and send a message to 1.15 if you're on router 1, or 4.15 or if you're on router 4, and so on. And you're going to use this protocol, this format. Use all caps get, G-E-T, space, the username that you want to get. So that would be Coder 3. And then your DNS server would respond with the IP address of Coder 3. And then you could write a new message directly to that IP address now that you know it. So practice that on your Internet Simulator if you're in a classroom with some other people connected. And then watch the next video on HTTP. That is this video, HTTP and HTML. So what is the problem that HTTP is solving? Well, let's start with this concept of HTML. HTML. This is hypertext markup language. Language. HTML. You might have used this before. It's mostly to show how a website should look. So basically it's got all the text, all the little formatting stuff that makes a website look the way it looks. And it contains all the content of a website. Now HTTP is the hypertext transfer protocol. So transfer means to send and get. So to transfer it across the internet. And what are we transferring? HTML. So we use the Hypertext Transfer Protocol, HTTP, to ask for the stuff that makes up websites. So once we find the IP address of the website we want to access, like code.org, then we can connect to that computer where code.org lives with its IP address, and we can ask with HTTP to give us the home page. And it'll respond with an HTTP message that contains all of the HTML that makes up the home page of code.org. So we can use GET requests from HTTP to ask for things that make up the website that we're connected to. There are also, just so you know, there are also POST requests. There's GET to ask for stuff, and there's POST to like fill out forms and provide information and things like that to a website. All right, so that's the end of that. And now we have completed all the layers of the internet that we're going to talk about. And so hopefully this rings a bell to you. So let's think about how all of these layers are involved when we try to access a particular website using the domain name. So if we went on Chrome or Safari or something and typed in code.org, how are these layers involved in getting us from just this little English name to accessing all these files? So let's remember from the beginning. We have the physical network. That's the wires and the routers and all the physical stuff that connects computers and devices and servers and stuff around the world. And then that's not quite enough for us to be able to actually talk. Then we need IP, which says every message sent across the internet will have a to and a from address. And every device on the internet has an address that you can use. And then TCP or UDP, depending on which situation is more appropriate, is going to handle the sending of our messages. So we can send TCP or UDP messages across the internet to different devices. And they're also going to follow the IP rules. And of course, they're also going to be sent across the physical stuff of the internet. So all layers depend on the layers beneath them. Okay, and now we have learned about DNS, which is a particular kind of TCP or UDP packet that relies on IP and physical network as well. And once we've used DNS to get the IP address of a website we're trying to visit, then we can use HTTP to ask that IP address to give us the files we want. And again, that relies on all of these layers underneath. There is an excellent summary of all of these layers and how they work together in an activity guide. So right here on your lesson resources, the first link. And it looks like this. It's got that diagram, and then it has information, summary stuff on all of those layers. So that's an excellent thing to check and to review to make sure you've got it, to make sure you're ready for assessments. And then here are our key takeaways. Scalability is the capacity for a system to change in size and scale to meet new demands. So the internet is scalable because its protocols are designed to continue working no matter how many devices we add, no matter how big it gets. The domain name system is the system responsible for translating domain names, like .com names, into IP addresses. HTTP is a protocol for computers to request and share the pages that make up the World Wide Web on the Internet. And then here's an important distinction. The World Wide Web is a system of linked pages, programs, and files that we can access on the Internet. The World Wide Web, or WWW, is about the content that we can access on the Internet. And the Internet is the system that we use to access that content. So WWW is different from the Internet. World Wide Web is files, web pages, media. The Internet is the network we use to access those files. And that is all for this lesson. So I will see you in the next lesson for our last lesson in this unit. Make sure you subscribe if you haven't already. Goodbye.